Hey everybody, thanks for watching another math video here. This one is going to be about solving quadratic equations, but this time they'll be in vertex form. All right, vertex form equations. We're going to solve those also. And sometimes the book calls those perfect square form equations. Never mind, it's okay. They can call it that. It's still vertex form, and you'll recognize it as soon as you see one. All right, let's take a look at this. All right, a vertex form, just to remind ourselves what vertex form does, it looks like this: y equals a times x minus h squared plus k. And what that equation gives us in terms of the graph is the coordinates of the vertex. All right, gives those numbers, the h and k numbers, those are the x and y coordinates of the vertex right there in the equation. That's cool. But let me just say this about any equation. All right, this applies to any equation. Vertex form, standard form, a line, exponential curve, it doesn't really matter. For any equation, if you replace the y with 0, you will find the x-intercepts of that graph. Okay? So we might be interested in finding the vertex of a graph, or the coordinates of the x-intercepts of a graph, I mean. So, you get the vertex right away from vertex form, but it doesn't give you the x-intercepts of the graph, and maybe you want those. All right? The algebra that I'm going to show you today will help you find those points on the graph. But the graphing is kind of a secondary consideration at this point. Really, what we're talking about is algebra. We're adding a couple of extra tools into your toolkit for algebra, all right? You already know how to do a lot of stuff on algebra, and you're going to learn a couple more things here in this video. One of those things is how you can take the square root of both sides of an equation. That might be a new thing for you. So you'll learn how to do that. You'll also learn a new symbol called the plus-minus symbol. And it's a really convenient way to write two different numbers at the same time. All right, and I'll show you where this comes up in our process. Okay, well, let's try one. Here's the equation 2 times x minus 3 squared minus 8 equals 0. And that would be the same thing as the parabola y equals 2 times the x minus 3 squared minus 8, right? And all we're doing is kind of replacing the y in that equation with 0. And that's how we'll find the x-intercepts of that graph. Okay, well, let's do the algebra. Whether we're talking about the graph or not, we're going to do the same algebra. So anytime you're solving an equation, what you're trying to do is to isolate the x in the equation, all right? And the first thing you would do to work towards that would be to add 8 to both sides, all right? Then you see that 2 times x minus 3 squared equals 8. You don't want to deal with the squared thing yet. You first want to get rid of the 2 by dividing both sides by 2. Okay, now we have the x minus 3 all by itself, x minus 3 squared, I should say, all by itself, and 8 divided by 2 is 4. All right, so now we have made some progress towards isolating x, but we're not quite there. All right, we're getting close, but we're not quite there yet. What we're going to do now, this is the new thing, is you're going to take the square root of both sides of the equation. All right, and if you look at that equation, x minus 3 squared equals 4. How do you get rid of the squared thing in the equation? How do you deal with that in the algebra? Well, this is how we deal with it. We just take the square root. Taking the square root reverses squaring, okay? So if you have x minus 3 squared, you can just reverse that squaring by taking the square root of both sides. And what's nice about that is anytime you take the square root of something that has been squared, it just gives you that thing all by itself. So x minus 3 squared, when you take the square root of that, you just get x minus 3. That's nice. It just kind of removes the parentheses and the square, the exponent 2, all in one step. It's really nice. On the right side of the equation, the square root of 4, well, I'm pretty sure you know that the square root of 4 is 2. However, here's where the other new thing comes in, and that's where you're going to add this plus-minus symbol here. As I mentioned briefly at the first, the plus-minus symbol is a way to write two different numbers at the same time. All right, those two different numbers are 2 and negative 2. So what we're really saying in that equation there with that plus minus symbol is that x minus 3 equals 2 and x minus 3 equals negative 2. We've got two equations now. because we need two solutions every time we solve a quadratic equation. You always have to get two solutions. And so this is how we get them. That plus minus symbol right there is our key to getting the two solutions. All right? Those equations are very simple to solve. X minus 3 equals 2 and x minus 3 equals negative 2. Yeah, you would just add 3 to both sides, and so you get x equals 5 and x equals 1. Voila, there's our solutions, all right? We get the two solutions one more time, folks, by using that plus minus symbol there. It's a critically important thing. If you forget to use it, then you'll only have half the number of solutions that you should have. So it's important. It's a small thing with a big importance. Let's try another one. X plus 5 squared minus 64 equals 0. Okay, well, I think you probably already know the first step there, and that would be to get rid of the negative 64 by adding 64 to both sides of the equation. Now we have x plus 5 squared equals 64, and right now we're going to take the square root of both sides. Okay, well, as we said, that square root of x plus 5 squared will just leave you with x plus 5, and the square root of 64 is 8, but we write plus minus 8, all right? So that's taking the square root of both sides and throw in that plus minus thing that happens pretty much at the same time in this process of solving for x, all right? Well, it's easy now. What we've got is two equations, x plus 5 equals 8 and x plus 5 equals negative 8. You solve each one of those simple equations by subtracting 5 from both sides, and you get your solutions, x equals 3 and x equals negative 13. Now, I threw that graph up there on the picture there because that first equation that we started with, if that was y equals kind of an equation of a parabola, that equation would tell us that the coordinates of the vertex of that parabola are at negative 5 and negative 64. The equation does not show us where the x-intercepts are, but what we just did by replacing the y with 0 and solving for x is we just found out that the two x-intercepts of that parabola are at positive 3 and negative 13. So it gives us more information about the graph, but really it's just about the algebra, all right? We're just learning a new algebra technique here. If we want to apply it to a graph, cool, but if you don't really even have to, maybe. Okay, let's do another one. Negative 4 times x plus 6 squared plus 100 equals 0. Okay, we got some big numbers there. So what? Treat them all the same, right? Subtract 100 from both sides, and then divide both sides by negative 4. All right, so then we work our equation down to x plus 6 squared equals 25. Okay, well now, what do? We take the square root of both sides, and that gives us x plus 6 on the left side and plus or minus 5 on the right side. So our two equations that we solve now are x plus 6 equals 5 and x plus 6 equals negative 5. No big deal. Subtract 6 from both sides, and there are your solutions. X equals negative 1 and x equals negative 11. All right, now you may be thinking, okay, I think I got this. This is pretty good. Let's kind of summarize the basic structure of this process of solving for x in vertex form. The first thing you want to do is isolate the squared stuff in the equation. And then you want to take the square root of both sides, and don't forget to throw in the plus minus symbol when you do that. Basically, that's kind of how the flow works. All the other little parts, by like subtracting 100 or dividing by negative 4, that's already stuff that you know how to do and you're pretty familiar with. All right, so these are kind of the newer things in this process. We're going to do a couple more examples to finish up this video, and they actually do show something a little bit different, and I hope you like it because it actually saves you a little bit of work, a little bit. Anyway, let's take a look at another example there. All right, so there you go. See it in the same equation, same structure, vertex form style equation. You would probably add 10 to both sides and then divide both sides by 2, and that gives you this, x minus 9 squared equals 5. Well, okay, so far so good, and you're still going to be using the next step by taking the square root of both sides. So you know you're going to get x minus 9 all by itself on the left side, but what is the square root of 5? Do you have to get your calculator out? And I'm going to say, no, you do not. You do not have to get your calculator out and figure this out. Yeah, the square root of 5 is 2.4-ish something, some kind of irrational number. Honestly, I want you to say, I don't care what the square root of 5 is. I'm just going to write plus minus square root of 5. And that's how you that's what you put in this equation. Don't worry about a decimal approximation or a calculator approximation for the square root of 5. Just go ahead and write square root of 5. plus minus square root of 5, I should say. And so now by adding 9 to both sides, we get this equation here, x equals 9 plus or minus the square root of 5. For a lot of people, that's a good enough answer just right there. That's two different numbers. I would like you, however, to write both of those numbers. One of them is 9 plus the square root of 5, and the other one is 9 minus the square root of 5. Leave your answers just like that in square root form. It's easier and it's 100% accurate. You have not rounded anything off and approximated anything. You've got the exact perfect representation for the solutions to this equation. All right, one more time to finish this up. And if you take another equation, another form, all right, let's do this one more time. You're going to add 6 and divide by 3, right? And then you get this x plus 1 squared equals 2. All right, cool. One more time. You're going to take the square root of both sides and throw in that plus or minus there up in front of the square root of 2. And so there's your equation. X plus 1 equals plus or minus the square root of 2. Now you just subtract 1 from both sides and we get this. X equals negative 1 plus or minus the square root of 2. So there's your two solutions, negative 1 plus root 2 and negative 1 minus root 2. And that wraps up this this example here. I hope that's enough to get you going. There will be an assignment kind of practicing these skills shortly. And if you have any questions, if I went too fast, or if anything I said in there was confusing, please write down the question in the forum or bring it to class and we'll talk about it. All right. Thanks very much for watching. I hope you're doing well. See you soon, everybody. Bye-bye.